So we are in Statistical Rethinking, Chapter 9, second edition of Statistical Rethinking, and we are on question 9H4. Now, question 9H4 builds off of what we did in question 9H3, which is the last video in this playlist, which was up here. Now, had I been reading ahead, I would have done both of these in the same video because there's actually a change that I needed to make in the code for 9H3 to do 9H4, okay? And I'll show you that change right now. Okay, so in 9H3, we were to run these two models here, okay? And that's what we did more or less minus the start values. The start values were not allowing the model to run on, at least when I was doing it. But the difference that we needed, or that we need to make for this question, for 9H4, is to add this little argument right here, log like equals true, okay? And so the reason is because in ulam, when we're using, stan, basically, if we're going to try to calculate WAIC or PSIS, we need the log likelihood, and we actually need to calculate the log likelihood. It's not something that the model is generating by itself. And so in ulam, in stan we need to hard code this, but in ulam there's a little convenience argument just called log like equals true. Okay, so I reran those models, and I'm not going to rerun them here, but those models from the previous question are ran, and okay. So for question 9H4, we are taking the two models that we ran, and then we're going to compare them with WAIC or PSIS and look at the effective number of parameters for each model. Okay, so it instructs us that we would need to use the log like equals true in order to get ulam to compute those, to compute the log likelihood which is needed for WAIC and PSIS. Okay. Which model has more effective parameters and why? All right, so we're going to compare these. So I'm just using the compare function. So we'll look at both WAIC and PSIS, although, it's basically, the results are going to be basically the same. So we run these. Okay, so we have the WAIC comparison on the top, the PSIS comparison on the bottom. And what we're looking for is the number of effective parameters, or the penalized WAIC or penalized PSIS. Okay, so just a couple of things to start with. Just notice that the WAIC scores or the PSIS scores, these are basically identical, and they both receive, roughly 50% of the weight. I mean, not quite, but these two models are very, very comparable. Okay, so but what we see is that the second model has fewer parameters, number of parameters, okay, which is the PWAIC or PSIS here. Okay, now the question is why? Okay, in case you have forgotten, which I should have addressed at the beginning of this video, the two models that we ran, they differ in one important way that I will point out right now. Sorry for all of the scrolling. But they're different in one very important way, and that is this argument right here. In the second model, we set a constraint on one of the coefficients, BR. Okay, this is covered in the last video, but just to remind you, where BR cannot have values less than 0. Okay, so we set that constraint. Okay, so when we come back down here, why might the second model, again, the one with the truncated coefficient, why might that have fewer effective parameters? Okay, and should we expect it to have fewer parameters? Well, yes, we should expect it to have fewer parameters. Why? Because we've cut off some of the parameter space that was allowable, right? So there's a smaller parameter space because we've truncated one of the parameters, and so the number of effective parameters should be decreased because of that. Okay, in fact, the way I just worded it, I like better than what I typed here. So when I get done, I'm gonna change this. But let me just reiterate: the reason that we should expect there to be fewer effective parameters for the second model, the one with the truncated parameter, is because in truncating that parameter, we have also truncated parameter space. How did we truncate parameter space? By setting a more restrictive prior on the second model, right? The truncated prior on the BR coefficient. Okay, and we'll call that good.